Cool. So this is Max from the future. The video about to see is me kind of progressing through the different stages that I've experienced in working with and into more agentic, let's say, ontologies of software development. Um, I think what's important to state here, I'm not a software engineer. I studied sociology with a focus on technology, so I did do some coding, but I'm coming into this from a more non-technical but very technically minded kind of perspective. So maybe some of the concepts or the words that I use don't necessarily match exactly the engineering mindset that might be behind it, but that's not the point. The point is really to show progression and to potentially inspire you to basically take a first few step, not just kind of chatting with an AI, but actually working with the AI as an autonomous system that you nudge and that you kind of shape which direction it takes, so that while you're in that process of learning, you actually get to understand what, in a way, the ontology of an agentic workflow is. And so that engineering becomes more something that is around the engineering the system that builds rather than building yourself. So this is all coming from my experience. Obviously, there's a lot of different parts and a lot of different ways that people can navigate into this space. This has just been kind of my way. So I want to share the progression from moving from manual prompting to starting to really think about multi-agent orchestration. The reason why I've kind of gone step for step is because I've been wanting to really have learning this with first principles. So of course we can just jump straight into multi-agent orchestration. If you Google a little bit, you'll find some frameworks and even some apps that will kind of help you do it. But for me, it was important to understand how we get there. So the first step that most people will start in is just manual prompting. I think it's pretty basic. I've prepared a little prompt to create a portfolio website for me in HTML, CSS, and JavaScript. I'm relating this to web design because I did web design. So I have a reference to that kind of working, although now I'm also progressing into coding as well, of course. So the way that I start is I would just prompt something. Obviously, I wouldn't be prompting web pages. I would build a web page, and then certain elements I might want to have coded for me. And so this would be typical. You would then copy this and just paste it into your website. There's also a way to do this that we can, which is quite interesting if you haven't discovered this. Let me open a new chat. We can go here to more. Oops. And we can do this canvas. And Canvas will basically write the code and then display it for me. So I'll just start this and then we can later have a look at it. So this is really like the first step for most people. I think engineers will also use this as a substitute for Substack. So instead of Googling my issue, I'm actually contextualizing the issue and then speaking with ChatGPT to get an answer. The next step in that manual prompting kind of context is working with an IDE. So this is VS Code, a relatively basic setup. Instead of copy pasting text in here, I can just prompt it. So read the index.html, tell me some improvements. So here an agent already has access to the files and will basically be able to read through it. And then if we prompt it to change something, it's automatically changing some of this code. And this, I would say, is the most kind of known way to use it, and is one where we're still in a prompting context. And also notice here, I've only said what it should do, but I haven't given it any context as to what improvements, like how do I understand what an improvement is? So I'm relying here on a generalized idea of what improvement is, instead of prompting it specifically. Okay, so it's created some suggestions, which we could obviously say to implement, and it would just implement it. We won't do it for now. Most engineers that I work with, obviously in my role as a team lead, I'm working with engineers who are now starting to use kind of IDE with chat. That's still how they're using it. So they might also analyze code with it, and maybe get the agent to actually replace code. But still, it's more of a coding assistant rather than an actual coding agent, let's say. Nonetheless, when we take a next step into the field of working, especially with an IDE, we're getting into the realm of skills. Now, skills is a pretty simple idea. It basically is just in a way, like prompt injection, where we save work writing prompts. So here I have the discuss skill. So look at the index.html and tell me about some improvements. What's happening here now is we have this discuss skill. You can see it, it's in codex/skills. It's a skill that we could also port to Claude Code or any other agent. It's kind of becoming a sort of industry practice for agents to know that they can access skills. Now, a skill always has a kind of small description, an aim, and it's something that we can explicitly trigger, as we did here, or we can also implicitly let it be triggered. So this is where, when we have prompts that we save in our like agent folders versus skills, a prompt can only always be executed explicitly, and a skill can be executed implicitly. So we might say, instead of saying like calling the skill explicitly, we could say discuss something with me, and then it would basically know, okay, I want to access the skill. So when it accesses a skill, it basically just injects this prompt that we have underneath it. This skill is just generally around discussing with the user before implementing it, because coding agents really love to code. So you might say, talk me through blah, 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 and it will just start implementing it even though you just want to talk with it. So a prompt like this can kind of coax it to really not implement anything first. So you can see here now it's it's got a framing, it's got an options, key improvements, and it's kind of going with me into a discussion. Although you can see, if you want, I can implement the single focused HTML pass, which is great because, well, as you see, coding agents want to code. So in that context of using skills, we also then get into a realm of skill frameworks, which has been quite an interesting place to dive into. Skill frameworks basically try to combine different skills, also in different orders. So one skill might call the next skill, might call the next skill, etc. One of these frameworks which you might have come across is called GST. And here you have kind of a very rich layered system of different phases which go through the building process. So here we have a discuss phase, which I showed you kind of it's a discuss skill basically. Here it's a phase, then there's a plan phase, an execute phase, verify work, so a testing phase, etc. And the different skills that are behind these kind of run in sequences. So we now basically on this level have these frameworks which guide the user through building software and improving software. The large question that we have in the context of code genning is also about memory, because if we keep kind of filling our context window and it needs to remember what it's building, at some point it might forget what the context is what we're building. If you've been working just in a chat, in one chat, what you might have noticed at some point is you'll be working with the agent just continuously in one chat. It will auto-compact it, at least in Codex. And then when you prompted something really simple, it might make a mistake where you don't really understand why it would have made that mistake, because it's such a simple context it should have been held. But auto-compacting basically destroys previous context in a kind of weird way, and also makes the agent quite inefficient. Because as I shared earlier, an agent wants to code and it wants to solve your problem. So if it has less context, we can kind of think about context. I think Steve Yegi kind of had this interesting analogy of a diver and its oxygen tank. If it runs out of oxygen, it's really quickly scrambling to solve your problem. So it starts to get quite dumb because it's like, cool, I can just do it this way, instead of actually thinking about it in a deeper sense and also considering the context it had earlier. And also these like 300k tokens, it's a little bit less because you have system tokens on it at the top as well, is actually not a lot. So it's kind of like a memory buffer that we have to respect. And we can't just fill infinitely. So because of this, we really have to ask, well, how do I then create memory that a new agent can keep calling onto? In the skill framework context, or on this stage of also my discovery, you'll find very markdown heavy memory allocation. I'll just show you, because I had, of course, also kind of created my own skill framework. The way that I worked with this is to have different markdown files in the initial phase where we're creating our kind of spec. We have a research markdown, we have a project brief, which kind of becomes the master context for what we're building. And then for the project management side, we have a roadmap context, roadmap markdown, and also the milestone slices, so kind of the tasks in a markdown format. And then on the left side, we have this code map, which would be also a markdown file. And basically, I'm trying to create a persistent memory of the project where different skills, so for example, the build is a build skill, the build skill would code and then write into the memory files what has been done on the project. The issue with markdown files I've experienced is they get kind of messy. And also to understand where in the process we are, like where on the roadmap, which milestone, which slice are we building, I had to also introduce kind of a persistent state JSON, which would basically be a pointer to the different slices that we're building in that moment. And as you can see, we now have like 6 or 7 markdown files that potentially will drift out of synchronization, and also files that we need to keep updating as we build. And Markdown has a bit the issue that if we're rebuilding a roadmap because we're correcting it, it's having to read through that whole context, and then it's having to kind of shift just a part within that. But it's just messy. It just gets a little bit too complicated, and it's not really clean because, of course, because we have such a small context space, which we can kind of understand as the oxygen tank, we do need to make sure that we optimize for basically enough oxygen to be able to work in. Okay, so that's kind of the memory question. So here in the skill frameworks, most people are solving it through markdown files, and we'll talk about the next stage of that. But anyways, in this context of rich prompts and skill-based frameworks, we're really still working very strongly here in this chat, and we're just going through in one big chat. And this is when I discovered the so-called Ralph loop. The Ralph loop is just a very, very simple while loop. Before I get into it, I would very highly recommend you to have a look and watch these videos. They're really quite crazy. They're done by Jeffrey Huntley, who ideated the Ralph loop and introduced it. It's just a very funny video to watch. But anyways, a Ralph loop is basically just a while loop where it looks through a prompt as some instructions, and it just finishes the prompt and then closes. So the idea is that, and this is just a bash loop, so we just spawn a terminal and read one prompt. When it's finished the instructions in the prompt, it will close. And I can show you that in a moment. The focus is here to have fresh context windows, because when we're working in an IDE, just working here, as I shared earlier, and we're compounding context, we're always having an agent that basically has no oxygen to work in. So what we do instead, when we want to build, we have to spawn a new window, and then we have to pin the context of the project. So in this case, if we have a look at, let's say, the watering guide, that's just my terminology for a Ralph loop that builds. You can see here, first step is study the brief. So here I have specs and I have a brief, so it's relatively simple. This is just my personal website brief. So the first thing we'll do, it'll study the brief. Then it'll inspect where we are in the loop. Oh, sorry, wrong one, watering. Then it'll inspect anything else in the specs, also including the code map. So I continued this concept. This, however, is not a it's a markdown, but it's not a hugely text-orientated code map. It's more of a lookup file. So what I want the agent to do is to get a glance at the code map and then decide itself where it wants to kind of build. We'll ignore the bead stuff. And then the task is just to implement the most important issue. Also, we're allowing it to choose which issue is the best rather than telling it to use the first one. then it's opening the issue, then it's implementing it and testing it, and then it's writing any changes into the code map. And then basically it just closes itself. And this calls on a script. It calls on the Ralph loop script, which I can also show you. We won't go through it at the moment, but this is, it's relatively long because I've added quite a few little features to it. But ultimately, it really is just read that prompt that we just showed, execute it in the background, and then close when you're done. So that's a Ralph loop. Let's talk about beads. So beads is basically an idea that instead of having, as I shared earlier, this like quite complicated markdown-based memory context, you basically have beads. Steve Yegge came up with this idea that, and it kind of goes a little bit into this idea of having JSONs as a state base. But here what we have, if we go into beads, go to issues, you can basically see just one of these is an issue. And it basically just says what the title is, what the description is, etc. And tells us what's kind of going on in our project. Important also is to be able to visualize it. So if we open our beads here, you can see there's just a list of tasks. And if we add a task, it'll just basically be open and it will be able for an agent to go in and then take it. The idea here is that we're kind of building a memory system on the side, or rather a task system on the side that we can use to actually build. I'll show you in a moment in action how this actually works. We'll get into that in a moment. Okay, so we've talked about beads, we've talked about Ralph loop. Here we're kind of getting now into a context where I'm not chatting with an IDE on the side, but rather I'm orchestrating what will be built. So I'll show you that. And then obviously we'll talk about a little bit multi-agent orchestration, which is kind of where I'm getting into now more and more. And I'll show you why that opens up when we start having Ralph loops rather than really persistent kind of like long-running agents where we're squishing the context. Tmux, just to quickly note, once you start kind of working with Ralph loops where you're working in a terminal primarily, it becomes quite self-evident that working in an IDE and having this chat open gets quite inefficient because you're having multiple chats open at the same time, and also you're working more on a kind of terminal bash style. So that's where Tmux, which is basically it's a multi-terminal functionality. So a typical terminal will just have one line or one kind of window, and here in Tmux I can actually have multiple open. So these ones are just that's just codecs. All right, so let's actually do a test here. The first thing that I want to do is I want to plan something. So I still use the IDE, but I don't use it to code with. I use it more as a kind of file explorer, let's say. So just to get a context, this is my personal website, which we already had open. And just for sake of demonstration, let's change this eye animation in the middle. So first we want to plan something. Plan a new bead where the ASCII eye animation comes red. Now what it's going to do, it's obviously already got a context in my agents.md as to how to call on persistent memory in the beads context. And also because we have the lookup table, it then can basically understand that we have this ASCII eye already kind of working. So now it's going and thinking about creating a new bead. So we can see it up here, make ASCII eye animation red. Cool, so this is now our kind of planning codecs window. And typically we would ask an agent to come up with the plan, and then we would implement it. I showed earlier that coding agents really love to implement code, but here, because I've just defined it to plan something, we've now just kind of planned it. So next, what we would be doing is we would want to trigger a Ralph loop. So the typical way we could say build issue px, what is it, q1s, and then it would build it here. But I don't want to do that because then I've got a context that is filled with that, and I would always have to open and close it. We could do that because obviously this is a fresh context window, but I want to show you how the loop works. So this is now just a reference to the bash loop, and we're going to just do one iteration. And what it's going to do, it's going to now basically look through the issues and basically build it. We'll see when it switches to in progress. And this is something that obviously we're watching now, but we could just have running autonomously. Because up here, if I wanted, I could also just, I could plan something new and I could spawn it. Okay, so now we have this task in progress. Awesome. And now it's going through the steps to create it. So it's investigating where it is, and it'll just kind of keep running. What's nice with this is now running, and we don't actually have to watch it. And we can continue planning something. Or if I had planned, let's say, 5 different tasks, we could then basically run multiple loops, or we could run multiple iterations of loops, and it would just go through it. And that's really the power. So you can see here now it's turned it red, which is cool. It's also going to automatically at the end commit it. Yeah, so this is kind of like this is not multi-agent orchestration yet. This is still, I'm prompting one Ralph loop manually. What I want to show though, so plan to change the, so this is also interesting. In my prompt for the watering guide, so again, watering is just my term for building to running a Ralph loop. I actually have here also, let's see where I have it. Okay, so it's at this point in the video that I make a mistake because I'm trying to look for why a new bug was created in the prompt, but it's actually in the agents.md. So agents.md is considered by any agent that is working. It's kind of like very top of mind. And here I have a prompt saying that it's to fix bugs while it's working, or rather to record them as beads. And so this is what happened. It was working. It came across a bug and it immediately issued it as a bead. And that's how this spawned. And then actually the agent goes on to fix it later. Okay, so what it's found here, it's actually found some sort of error. So in the test, it noticed that something was off, and it's actually created another bead, which basically is now an open project, an open issue, sorry. So from here, we could, if we're running loops in loops, then the loop would now see, there's another open issue. I better go in and fix it. And then it would basically just start up another loop to basically fix it automatically. This can become a little bit dangerous if it's a fix that is, if there's an issue inside the loop itself, the loop will try to fix itself while breaking itself, while trying to fix itself while breaking itself. I've had that happen a couple of times. This is where Jeffrey Huntley kind of talks about this context of it's more like clay. So we've gotten not into a mode of deterministically writing code, but kind of like shaping code and shaping a project. And also here, instead of reviewing code, if something doesn't work, we want to then again kind of come from the agentic context of the agent then in a new context, understanding what's going on there, and then kind of shaping. So we're shaping the project, but we're also shaping the prompts. So if in the past we would be building one prompt in a kind of typical chat-like manner here, now what we're doing is we have this kind of master watering prompt, which again is just my build prompt for a Ralph loop. And we could now go in and adjust it slightly. So if it keeps making the same mistake, we could here say, watch this, don't do that, etc. Okay, so I think this is a good place to end this. What's important here is once we have the understanding and the practice of being in Ralph loops, obviously our next step is multi-agent orchestration, which I've alluded to already. If we just have one task open, obviously it's just going to be one loop. But let's say we have 40 tasks with 5 or 6 different epics. we then could have an orchestrator take care of one whole epic, or to spawn multiple Ralph loops simultaneously, because in the planning stage here, we can also include dependencies, which would then help us to understand, can I run two issues at the same time, or are they going to get in their way? I'm running Git on this project, and of course, when we get into multi-agent orchestration, we're then also having to think about merge conflicts at some point, but that's another thing that just arises when we run multiple loops at the same time. And the last thing I want to share is this idea of agent messaging, which I'll put a link also into this post, is that when we have multiple agents running, if they have persistent kind of identity, we can also start to send messages from agent to agent. So one agent may say, "Hi, I'm working on this file. Please don't touch it," or to inform, "Hey, I've done this and this. You can now kind of do the next step in the process." Anyways, I'll put a bunch of links into the post as well for you to have a look at. And I think the thing that you can get away from this is that building into working with multi-agent systems is one where you want to have an idea of the progression going into it, because the complexity and the speed at which this field is moving at is obviously very, very high. And if you don't understand the primitives, then you're going to get confused as to why things are built the way they are. And also, we're already at a point where the expertise of the models is so high that it's not necessarily about having the best model, but rather about understanding how you build workflows of building software that isn't reliant on you as a human. So the human in the loop isn't anymore the one who is in the first step reviewing what the agent has done, but rather modeling, like shifting around which direction the agents are taking, because they're just going to be running. And while they're running, you want to kind of nudge them in certain ways to get what you want. So here we're moving from coding expertise and kind of software development in the sense of coding the logic that you want to have, to actually shifting to software engineering, where you're engineering an environment for someone else to code into. So you will be presented with the hard issues that obviously arise when you're doing software engineering, but you're presented with them in a different way, where you're thinking about it on a more higher level of abstraction, rather than thinking about the actual code, how you shift that around. All right, I hope this was helpful. Wishing you a lovely day. Ciao, ciao.